So this is the continuation of Chapter 5.1, Pre-Calculus 11. It says here, working with radicals. So you have the ability to add and subtract like radicals. And so in this particular example, the actual radical is square root 2. There's another square root 2. You can add these coefficients. So there's a 3 and a 2. So what we can do is, because they're the same radicals, this becomes 3 root 2 plus 2 root 2. Well, that works out to 5 root 2's. Alright, so we're going to move on to the first set of examples. So 7 root 3 minus 2 root 3. Notice the root 3's are identical, so it's going to be 7 subtract 2. So that just works out to 5 root 3's. It's sort of like the same thing as adding and subtracting like terms, as long as the terms are the same, meaning the variables. So here we're moving on to negative 5 cube root 10 minus 6 cube root 10. Well, notice the cube root 10's are identical, so it's really negative 5 minus 6, and that works out to negative 11 of them. Cube root 10. Don't forget the index of 3. Here we got 4 square root 2 minus 5 cube root 2. The radicals are not exactly the same, right? Notice that this has an index of 2, this has an index of 3. You can't simplify that, so the final answer is 4 square root 2 minus 5 cube root 2. That's it. There's nothing more you can do. Okay? Now, here we have 2 cube root 75, square root 75, sorry, plus 3 square root 3. Now, it looks right now like you can't add or subtract them because the radicals are different, but in fact, you can simplify this mixed radical. 2 cube root 75 from our previous lesson can be written as 2 square root of 5 times 3 plus 3 cube root 3. And notice that we have a pair of identical numbers because our index is 2. We can bring that pair of 5's out as a coefficient, so that becomes 5 times 2 is 10, 10 cube root 3 plus 3 cube root 3. Now the radicals are exactly the same, and so we can add them. So this becomes the final answer of 13 cube root 3. So moving on, I know that I'm running out of space. Minus or negative square root 27 plus 3 square root 5 minus square root of 80 minus 2 root 12. Right at this moment in time, it doesn't look like you can add or subtract them, but if you make them into, or simplify them into mixed radicals. So negative cube root 27, I'm not going to bother showing you, but I know that 27 is 3 times 3 times 3, so I can pull a pair of 3's out, so it'll be negative 3 root 3 plus 3 root 5. You can't simplify that any further, so that's 3 root 5 minus 80. Square root of 80, well, that's actually 2 times 2 times 2 times 2 times 5, and so that works out to 4 root 5 minus 2 root 12. Well, 12, you can simplify that down to 2 times 2 times 3, so that becomes negative 4 root 3. Now, these two you can combine. These two you can combine. So this becomes negative 7 root 3 and then a negative 1 root 5. Again, I apologize for my handwriting. Moving on, negative 9, square root of 9b minus 3 square root of 16b, b is greater than or equal to 0. So now we are including variables. Well, that's okay, that's the same thing. I know that the 9 is 3 times 3, that's a pair of them, so that can be written as 3 root b minus negative 3 square root of 16b. Well, 16, I can break that down. I can grab a couple of pairs, that becomes negative 2 times 2 is 4, negative 12 root b. Now I have the same radicals. That becomes a final answer of negative 9 root b. Moving on, restrictions. It says if the index is even, the radicand must be non-negative, or the radical is undefined. To find the restriction, set the radicand greater than or equal to 0. then solve. So in this particular case, all these examples, my indexes are even. Oh, sorry, the first two are even. What that means is that what we can do is we can say 3 minus m has to be positive. So how do we set that? Well, it has to be greater or equal to 0. So how do I solve for m? Well, we basically assume that the greater than equal to is almost like an equal symbol. So we'll just use basic algebra. So we're going to add m to both sides. That gives us 3 is greater than or equal to m. Now normally we never leave the m on the right hand side of any equality or inequality, so I'm going to write it as m is less than or equal to 3. What that means is that any m value inside this radical will make this solvable. Okay, so any m value smaller than or equal to 3 would work. Moving on to the next example, because my index is even, then I have to say, well, 2x plus 5 has to be greater than or equal to 0. So using basic algebra, how do I solve for x? So I'm going to subtract 5 from both sides. So that becomes 2x is greater than or equal to negative 5. X is greater than or equal to negative 5 over 2. Now, notice that this time the index is odd. Well, because it's odd, there is no restrictions on x. X can be an element of any number. It can be anything. Because if x was positive, you can still take the cube root of it. If x was negative such that you add 2 and still negative, it's still possible to take the cube root of that. So that's not a problem. It says odd index radicals have no restrictions because, well, the cube root of 8, well, it's basically 2 times 2 times 2. The index 3 says, do you have 3 of a kind? The answer is yep. It's just 2. How about the cube root of negative 8? Well, negative 8 actually can be written as negative 2 times negative 2 times negative 2. Do you have 3 of a kind? Absolutely. So notice that in this case, when the index is odd, you can have an answer that's either positive or negative. So when odd indices, there are no restrictions. And hopefully that makes sense.